Right. So next video, I'm going to show you how we're going to evaluate how OCR did by using Project Gutenberg. Now, Project Gutenberg is a great website where you can sort of see the text of books that are out of copyright. So I did The Wealth of Nations because it's out of copyright, a very old book, and you can actually get a free ebook from this. Different formats you can use. Just for example, here's the plain text. So yeah, it's really cool. Don't overpay for books, especially if things are under copyright. And it's a great set of training data for what we're working on. Because, I mean, how great is it that someone already wrote out all the words of a book and you don't have to do it? Also, history. A lot of Google OCR, I believe, was trained on books kind of like this, where they did mass book scanning in libraries and analyze things. Not sure if they actually used Project Gutenberg, but I'd speculate they did. Anyways, let's get started. So first up, we're going to do a little bit of web scraping to get the text out. There are libraries to work with Project Gutenberg, but I didn't really like their code quality and their interface. It just didn't seem worth it. So sometimes simple is best, and using the actual website I found was best. Yeah, so this is Beautiful Soup BS4. It sort of helps you look at HTML output. If you haven't ever seen that before, I'll show you what it looks like here. So I'm in my web browser. I right-clicked and found Inspect Element. And you can actually see what the code is that the browser is using to show you the page. Very useful, cool stuff, I think. I actually want to do web scraping using OCR in the future. It's just sort of hard to get the browser to give me that control and do it quick. So that's something I'm kind of working on. If you have any thoughts on that, feel free to drop a note or something, because that could be a real cool way to do an ad blocker. Anyways, so let's say we're trying to look at the table of contents. I can right-click here, inspect. I can see there's a link to chapter 2 with this sort of pound sign. That means ID. So see, if I click that, it takes me to the ID of chapter 2, which is book 1. Sadly, it looks like Project Gutenberg does a little bit of a funky standard scheme for naming their divisions. So that's this div class chapter. Where are we at here? Sorry. Here we go. Name chapter 3. So it's called chapter 3. That's because sequentially it might be the third chapter from their database, but really it's chapter 1. That's kind of annoying. Not the end of the world, though. Anyways, I know that our pages came from chapter 1, as it's called in the book. We're going to use that going forward. The third chapter, that means ID of 2012. And here we go. So here's what the text looks like. Everything is broken up by paragraphs. That's this P tag. H2 is a heading. So we kind of got the text, but we need to sync it up just a little bit better to align things. So we need to take this HTML and process it so it looks kind of like this to compare the two. All right, handy dandy glob. This time I'm getting text. And here's just a list comprehension. So I'm saying find me the second chapter, find me all the paragraphs in that second chapter, and then combine them by a new line character. That's the \n. Print that. Here we have the greatest improvements in the productive powers of labor. Greatest improvements in the productive powers of labor. Great. Kind of lines up. Capitalization is different, however. So that's another thing we'll need to work on. So yeah, first step, we're going to align the two texts, and then we'll do some basic cleaning to handle things like capitalization. For an audiobook, I don't really care about capitalization. It can kind of matter if someone's like enunciating a part in dramatic effect, but that's a little bit more complicated than our use case right now. Yeah, so we'll clean up a few other things too. I'll go over shortly. Here we go. So the OCR text starting on the 220th character. Sorry, the 220th index, the 221st character, sort of aligns with Project Gutenberg's first character when we do it by chapters and exclude the headers. So get to know, we're going to do that as our sort of front filter. Here's cleaning the text. We're removing hyphens because Gutenberg merges words where in certain books or in printing, they'll, like educated, they might do educate and then -ed on the next line. So that's going to fix that. We're standardizing spaces to just be, 1. And then we're getting rid of any leading spaces because sometimes that can happen based on how we're cleaning the text. Also lowercasing everything. Here we go, test text. It's OCR text starting at the 220th index. I will show you, I don't have it here, but here's the test text. Then true text. It's Gutenberg. We trust them. And boom, lines up. Yeah. All right, so next step, we need to find where they end. It should be relatively similar. So I'm just looking at the last 20 characters of the test text, comparing it to where that is in the true text by using the index function. It does look like everything lines up okay. These are pretty close together. So when I look at this, when to make them became the, kind of looks right. So here I am getting the pattern index and then offsetting by 20 length, which was the pattern we matched in. Index matches on the beginning of the phrase you're matching against. So I'm just adding the length of that back so we get full text and don't exclude the match text. All right, so our text is aligned. Exciting stuff. We're sort of about ready to move into actually analyzing our accuracy here. So I found this paper in this good library. I've done a little work with comparing OCR output to a set of true output, and these are some standard metrics. So I would encourage you to take a look at this paper a little bit. It goes over different metrics and some of the nuances of them. One thing to call out, let's go over this here, are what an error is. So when you're comparing two words, let's say, I believe I do examples down below. Yeah. So when you're comparing two words, you could sort of say, what's an error? So that could be like comparing what should be bat, but you found cat. In that case, it takes one substitution to go from cat to bat. So that's sort of an error of distance 1. So you sort of look at how many substitutions it takes to get from one thing to another thing. You can also look at deletions and insertions. So it's sort of like take a string and how much could you change to get to the next one. That's what's called the edit distance. And that's the common metric that is used. And also you can look at sort of exact matches. What these all are is, I wrote it down here, word error rate, match error rate, so that's like an exact match. Information lost. I kind of forget that one actually. But generally you want to lose the least. But yeah, so I just used this library because it was quick, easy, and implemented all these things for me. If you want to look at the character accuracy, just take the CER, character error rate, 1 minus that, and you get how accurate it is. So 1 minus the error is how accurate you were. In this case, our character accuracy rate was 98.2%, so generally pretty accurate. If you look at the hits, quite a lot of exact hits, some one-off substitutions, few deletions, few insertions. So again, clearly OCR is in the ballpark. What we've done does kind of match up the chapter. It's not perfect though, so we should at least look at what is wrong. Now we're using the Python standard library difflib, and it's nice for seeing the difference in text. So here we go. I'm comparing, what is this? I'm comparing words, split with no arguments, just does things by space. So that's how that works. And here we can see there's an error. The true text was improvements, I believe. The test text was improvement. So that's not a big issue. It's just a simple losing the S for an audiobook, that really doesn't matter. Even for reading, it might be annoying, but errors like that I'm not too concerned with. Same with punctuation. Missing a comma, not a big deal. I'm not too concerned about it. But yeah, when I looked through this, a lot of the errors were pretty much that. Some actual things were missed, like the division of labor on one part. I believe that was the header of the text was added incorrectly. That's why there's like page number 5 had that, for example. But yeah, comma or semicolon again, nothing too concerning here. Nothing that made me think like, oh god, this is trash. But we're just going to add a few more things to make our comparisons a little bit better. We're gonna same things as before. I found an issue with a nan thing entered in there. We're just gonna always get rid of that because it's gibberish. Also, we're just gonna restrict our characters that we compare to numbers, letters, periods, because keep it simple. That's what mostly matters in things. Yeah, you could also add like apostrophes and other stuff. Also, I should mention there's a library called NLTK that is a lot of stuff like this, a little bit more involved than the type of work we're doing here, but it is a useful library to look at. All right, so we cleaned the text. We're just going to line them again, same way before with that index thingy, and then I put all the measures together, including error rate and accuracy rate. So our character accuracy rate has bumped up to 98.6. Errors again, a lot smaller now. And we still sort of see that page number thing, the division of labor 9, kind of annoying. That might be worth fixing with the audiobook side of things, but again, nothing too concerning for me. Yeah, overall, pretty good for 6 pages. There was a phrase down here that does appear to be incorrect. Could be worth looking at, but again, I'm just trying to get the core building blocks, and then over time you can decide which one needs improving to make the output that you care about better. All right, so after this exercise, I feel pretty good about things. We're going to do the final output cleaning to make things good for an audiobook. So when you do audiobooks or text-to-speech, you take text, make it audio. Having like new lines does tell the computer, hey, this is a paragraph. Wait a little bit longer than a sentence. You can also add more custom things to sort of add like intonation to how it's spoken to be a little less robotic. But in general, the models have been getting a bit better, so it's not too Microsoft Sam, if you remember who that is. Not too robotic, but could cost something though. Anyways, other issue, our OCR text doesn't really have paragraphs caught into it. It might be worth going back, adding that information in there by sort of processing the OCR output a little bit better than grabbing all lines like I did. But this is good enough for me to generate the audio file. All right, here's some notes and further work. I'll just leave that for you to read. All this, again, is always on GitHub, so take a look. If you have any questions or comments, or even want feedback on a project idea you're thinking of, feel free to drop a note. I'm happy to give you my thoughts. Thanks for watching.